All right, so just wanted to thank the SPDM for giving me this opportunity to speak today. I'm Paul Thompson, Vice President of Talus Technologies, Talus being the creators of the Seismic Data Management Software Exploration Archives. And today I'll be presenting some insights into using AI and ML for your seismic data management. So there are three topics we're going to look at today. The first two being just topics to we're just going to look at briefly to really set the stage for the main topic, which is managing more data with AI and ML. So first, what is required for real-time access? It's much more than just data being online. Then we're going to look at adapting to change like OSDU, cloud storage, cloud processing, AI, ML analytics, and just looking at what's next. Lastly, due to real-time access needs and the need to adapt to change, there's more that has to be done with your data in the first place. And so we'll look at how we can manage more data using AI and ML. All right, what is required for real-time access? I look at it as a very simple concept. First, it's finding the data you need quickly. And second, it's being able to access that data when you need it. It's impossible to achieve this without proper practices and standards. AI/ML does not replace the need for proper practices and standards. It's just another tool to help you. Is everything online? Data being online only helps with accessing the data. It does not, if not done properly, it does not really help you with finding the data in the first place. If you don't manage it properly, I kind of look at it as this picture that I have here, which is how do you find a rock that looks very similar to all the other rocks without the proper information to identify it, without it, you envision it kind of highlighted in that pile. So what if you have thousands of similar files, all with similar attributes, all of which matched your search criteria? Do you have to look at each file individually to find the correct one? There are some areas in exploration where not only do you have hundreds of SegWi files for a single survey, but you'll have many overlapping surveys, merge surveys, and more. So with the end result being thousands of SegWi files for a single area of interest. And furthermore, these files could be terabytes in size. So you can't simply open each file quickly to find the correct one. Not when you need to download a terabyte size file before you can get a good look at it. So how does a geophysicist know which file they need and how can they determine that quickly? Next, just because you have access to a file, what do you have entitlement to and what has had entitlement expired on? And then lastly, if you have entitlement and you can find the file, is that file workstation ready? So is that file, does it have the correct information in it? Has it been QC'd before it was uploaded? Is it in the correct units? Is there a bin grid definition defined? Is there correct CRS defined? Are there spikes in the data? So basically, can you properly use it? So even if you get down to the right file, was it QC'd in the first place before it came into your system? So really, just to summarize that, just because something's online and you can access it and download it doesn't mean you can find it quickly. It's more important than ever to have proper processes and procedures. This combined with the AI/ML tools can help you semi-automate the upload to the cloud or wherever you're storing your data. Later on in this presentation, we will review some of the data management tasks that can be fully automated with AI and ML, and then we'll also review some of the tasks that can only be semi or partially automated, and then finally we'll also take a look at some of the tasks that really can't be automated very much at all. So there's a variety of things to do to get your data in a proper format such that someone can find what they need quickly. All right, so my next topic is, can you adapt to change? Can you use that next latest and greatest processing or interpretation software easily, or are you held hostage by using your software from a certain company or vendor? Can you use the latest AI and ML to assist your geophysical team? So not AI and ML on the data management, but AI and ML on the processing and interpretation side of things. Can you use cloud storage, cloud compute, HPC, AI, ML, and analytics? So those are all things that have been coming up in the last few years that, it's the question is, are you able to leverage that? Uh, with cloud storage, you have now on-prem storage, you have public cloud storage, private cloud storage, or hybrid storage. So storage is really just a commodity, and you need to be flexible with it. What's best today may not be best tomorrow. So with cloud, you have a variety of low cost, slow access, and you have high cost, quick access. What is that combination of storage that you need? Are you utilizing your online, your nearline, and your offline appropriately? With Seismic, when you're dealing with volumes that are terabyte in size, I believe it's very unrealistic to think you can have all of your Seismic online on very fast spinning disk. Here's another big change. Yes, storage technology is changing to allow storage of larger files. However, I would argue with the density of your SegWi, it's becoming larger faster. And so your files are getting bigger, more so than cloud providers are allowing the storage of larger files. That, and you add to the fact that in any with any operator, you're really only their teams are really only looking at between 5 and 10% of your SegWi library at any one time. And so how do you determine what that 10% is and make sure that that 10% has the fast access? How do you make sure your other 90% is in a little bit slower access so you're not paying too much money? So that's what I mean when adapting to change is can you with the cloud environment, can you move your data around such that what you need to be in fast access is and what isn't is not, so that you're not really paying too much? And then here's another big change, OSDU. And so it's OSDU started in 2019. And if I had to guess right now, there's probably more than 1,000 people working on it full time. Most, if not all of the super majors are involved. The goal of OSDU is to break down the data silos, remove the barriers so that multiple systems can be used and view and work with the same data at the same time. So imagine a time when multiple different geophysical teams can use multiple different interpretation systems from competing vendors without any problems at the same time and on the same data. So you're no longer held hostage to just use the software from this one company or this other company. And it no longer takes a year or two to migrate from one system to another system. Will your data management practices allow you to utilize OSDU? So just real quick in summary, adapting to change. Technology is moving very fast. The biggest change here being AI and ML. Are you leveraging this change and are you able to make a significant difference in your business? All right, so now on to the third topic, which is kind of the main one. I'll spend a little bit more time here. And this is all about managing more data using AI and ML. Technical data managers have always been asked, have always been difficult to get budget. At least in my experience, it's always been difficult to get budget in data management. And now people are being asked to do more with that same set of resources. In our experience, AI and ML and analytics can only be used with your Seismic if your Seismic master repository has well-structured and well-quality controlled Seismic data in the first place. A data manager must have well-defined processes and standards along with the proper tools. And can AI ML be used to increase efficiency of the ingest, the QC, and the catalog process? All right, so let's get started with some of the AI and ML that we're using. So the very first top picture is image versus word recognition. So this is an example of an image recognition AI algorithm. And what I mean by that is you can send pictures or images to this algorithm, and it can then determine, okay, this is a contract, this is a processing report, this is a map, this is observer report. And so the AI engine, it gets trained to say, okay, if the image looks like this, then this is what it is. And so that's the first piece of AI ML that we're using. The second part is actually more important in my mind, and it's actually we're getting better results with that second one, which is text or word recognition. And so with word recognition, we'll send our algorithm a full string. And so that full string is that directory path that you see there in that middle image. And instead of asking the AI ML algorithm, is there a survey in this string? Instead, we found we get better results when we parse apart that string and just send simple words. So we send public to the algorithm and say, is public a survey name? And then we'll send teapot dome to the algorithm and say, is this a survey name? And we'll send each word, and then we'll essentially get a rating to say which one it thinks is the survey name. Along with the file path, we can always also look at things like your EBSDIC header because it's essentially text-based. So we can do the same thing with your EBSDIC header. And instead of sending the entire EBSDIC header to the AI ML algorithm, where we really don't get very good results, what we do is we go through the entire header and we create what we call tokens. And so we'll create a token of every individual word, and in some cases, combination of words. And so you'll see in that second image where we say, is petroleum a survey name? Is teapot a survey name? Is dome a survey name? And then lastly, we also combine some words and say, is teapot dome a survey name? And that's where, we get the good results. And so that's really the key here that we found with using the word recognition AI. It is about parsing it apart first and then sending all the variety of different combinations of words to your algorithm to see what percentage it thinks for each one. So in this example, I talk about survey name, but we're also pulling out line name. We're looking, or sorry, seismic 2D line name. We're looking at things like acquisition company, processing company, type of seg-y data, whether it's gathers, velocity, post-stack, pre-stack, your coordinate reference systems, and things like that. So here's just a kind of an image from our software of one of those AI ML tools. And so when you're cataloging, it's not lights out. So the AI and ML is going to give you some results like, okay, I think it's a 50% accurate result, or it's a 90% accurate result, or it's a 100% accurate result. So you still need that QC person there to help determine, okay, which one should I use, maybe even doing some spot checking. It's really just another tool to help you get through larger quantities of data quicker. You still need their proper processes. So what happens, let's just look at what happens when new data arrive. So yes, I can use AI and ML to help identify and classify. So those were kind of those previous slides, using it to help identify and classify what it was. Second, I can use AI and ML to help detect duplicates. And so I can perform checksums and detect duplicates automatically behind the scenes. However, some of the tasks I can't really fully automate would be, for example, checking a contract to review that I got all of the deliverables I'm supposed to. We can partially automate that, and we're doing some things with AI to help pull things out of contracts, but you can't fully automate, did I get everything out of a contract that I was supposed to? Another thing that we don't really recommend fully automating at this time is just validating your navigation. And so there's a little bit more, so there's some hands-on that has to be done when validating your CRS and validating your navigation. And then finally, when actually scanning the seg-y files, there's actually quite a bit of automation we can do to check byte locations, bin grid information, and all of that other stuff. So again, with your seg-y, there is definitely some automation we can help you with. All right, lastly, what about capturing your relevant entitlement and obligation information? And so this is very hard to automate. We are working on some algorithms, AIML algorithms, to pull information out of contracts, but it's very high level information at this time. The parties involved, expiry date, types of contracts and things like that. When it gets to kind of detailed lists of surveys and products and what's your expected deliverables, it's a little bit more difficult to get an actual true representation of that. But we're working on it. And so it's important to get your entitlements right, especially when everything's going to be available online. That is actually one of the requirements of OSDU, is that you have your entitlements and your obligations defined so that OSDU can manage that for you behind the scenes and not accidentally let someone from an affiliate company access information they're not. Or maybe you have third-party vendors working for you and they're not allowed access to it. Where are you controlling that? What about when you have derivative products? Are others allowed to access those derivative products? So really important to manage your E&O appropriately, and not all of that can be automated with AI and ML. Right, so just wrapping up here, because I wanted to leave about 10 minutes for questions. So what are your goals? And so having a proper Seismic master repository so you can manage your millions of files yet still be able to track down a single file quickly. If you tried to just upload everything automatically without a data manager involved, without proper processes involved, the image on the left is kind of my analogy for that, is over time you would just have a mess. You would not be able to find what you need quickly. And even if you could find it, would it still be in good shape? Or would the SegWi file be non-QC'd and hence have problems? You really need to have proper processes and standards in place so that you can achieve essentially the analogy on the right with a clean warehouse. And then secondly, you need to be able to adapt to change. Today, it's all about cloud compute, cloud storage, but what's coming tomorrow or what's coming in 5 years or 10 years? You need to be able to adapt to change. How can AI help you? So I've already kind of showed how we can use AI and ML to help with classification and identification of data. We can help with determining data duplication, and we can even help with QCing, validating your SegWi files, things like byte locations and CRS, and whether there's spikes in your data and things like that. So there's a lot we can automate fully. And then there's a set of things that as much as we can semi-automate, there still needs to be user interaction. So that's things like auditing your navigation, validating expected deliverables versus delivered files, and then also validating your entitlements and obligations. So semi-automated, but not fully automated. And so lastly, just one last comment. With so much more needing to be done, I'm not sure we could achieve this with the same resources without the AI and ML tools. So it is really just a tool to help you be able to do the more work that you're being asked to do with the same amount of resources that you've always had. So on that, I think that is it.
Thank you, Mike. Thank you, Paul, for giving very exciting solutions, incorporating of AI in seismic data. We have some question here, and first of all, Luis asked, where is AI best used currently? Deep applications, storage inventory management, or something else?
Well, for our perspective, we're using it simply to ingest, catalog, and QC new data. And so we try to classify it and essentially save metadata for your online files so that you can quickly search for what you need. And so it really is key still to have really good metadata so that you know, okay, these are the 5 workstation ready files associated with this survey that I'm interested in looking at. So the metadata is very important, and that's what we're using AI ML for, is to populate that metadata.
Okay, actually, Mr. Don Robinson asked about, can you generate queries and then pass the result to the other applications or reports to be used by other companies? If we collect metadata, can we send them back to you to update your data model?
Yeah, absolutely. So there's many scenarios where we work with other applications where those applications are feeding us additional information, and then that information can essentially be uploaded, stored as metadata as well, and then help with that end user query capability of finding what they need quickly.
Okay, that's great. And I have a question of myself. What do you suggest? Just putting seismic interpretation onto cloud data, or accessing process data by several users at the same time? Which one is your approach?
Well, for both of those, the first thing that pops into my mind is OSDU. OSDU is meant to be a cloud native system that you can interpret and process from on the fly. And so it's meant to work with the cloud, and it's meant to have when it's ready and the interpretation systems out there start reading and writing from OSDU, you'll be able to do it simultaneously from many different applications, streaming it on the line or online on the fly.
Okay, that's great. And we have another question from Tichov. Paul, when do you analysis are you also working on new displays to help the experts to efficiently make the calls? Thinking as examples, graph technology for spotting duplicates. What's your experience, and can you share ideas where this could go?
Yeah, so most of our expertise is on the ingest and cataloging QC and process management of the data management. So it's on all the work we do beforehand before that data gets uploaded to the cloud or to your storage solution. So that's where most of our work is done. And absolutely, we do have some visualization tools for when it comes to checking duplicates. With segvi files being so massive, we don't checksum the entire file because that would take too long. But we have different tools for checksumming and finding duplicates in segwi data and then presenting that results to you. But in the end, that's just a part of that ingest, that QC process. That's really our focus. When it
Yeah,
comes to visualization on the other side, we partner with other people for that side.
okay. And we have another question from Jess. Is there a use case for flagging which data has been classified by an algorithm and which has been human assisted?
Yeah, so we don't at this time, only because we view it as when we use our AI and ML, it's not a lights out automatic, it's now done. We essentially use that to present the results to kind of that data manager. So that data manager is still that gatekeeper of checking all the results, even doing some spot checking of stuff that's a high percentage. And so we're at the stage where we're still having that data manager involved to check everything. I can see as we go into the future where, you know what, they've been using the tools for so long, they've never found a mistake or they rarely find it. So let's just fully automate it all and push it right to the cloud or right to kind of the repository. At that point, I can see how it'd be very useful to have more flags to say, okay, this was fully done, fully automated. No, a user did not look at this, or no, someone did not get involved.
Thank you. And we have another question from Luis. Has your AI machine learning cataloging tools been used on a real life mass digitization effort?
So yeah, we have two operators that we've used it on, and those are actually were the ones that helped us find the right algorithms, to be honest, because we tried many. So first of all, we didn't make our own AIML algorithms. We used published ones, and we actually had to try a number of them before we actually found a good fit for seismic data. Furthermore, we also found that the bigger your training data set, the smarter it's going to be. But we found we could not combine training sets from multiple different companies just because their naming conventions were slightly different and just the way they managed was slightly different. So we found actually each company had to kind of maintain their own training data set. And then, yeah, between that and trying different algorithms, we finally found one. And yes, we've used it for with two at this time. Again, we're kind of we're still just past the starting line, and so it eventually will be used by all of our customers.
Good work. And there is another question from Alan, and I think already you addressed that, but please just clarify it. Alan asks, Did you have a quality flag in your metadata that the data has been QC'd by a human?
Yeah, we do have that as well. So we do have QC flags, when it was, what date it was, what status it was. We have comments, and so that is there as well to go along with. Well, we don't have the AI flag, but we definitely have the human quality control flag at this point.
Okay, thank you for all the answers and your presentation. And I think I just covered most of the questions. And please add anything that you want to at the end of your presentation. And I think we cover all the questions right now.
All right, thank you for all the great questions.